All right, so thank you for joining the team at Hands-On Labs today for our discipline-focused live demo series. Today's topic is dedicated to HOL's chemistry online curriculum and kits. Before I hand the mic over to our host, let me take a moment to review the webinar logistics and give a brief introduction on today's event. We encourage our attendees to participate in the conversation by asking questions and sharing resources. Please use the chat function to join in on the conversation. Be sure to toggle to the window All Panelists and Attendees if you'd like the entire group to see your comment or question. If you have any questions, add those in the Q&A box. You can find this in the section in your toolbar. We have several distance learning specialists on the panel today to help answer any questions you have in real time. For questions pertaining to kit cost and customization, please work directly with your dedicated distance learning specialist once the webinar concludes. Dr. Duane will address any remaining questions at the end of the demo so you have clarification on important topics. We'll start the presentation with a quick poll to gauge our audience temperature on their past experience with online teaching. To participate in the polling segment, submit your response when you're prompted with the poll pop-up. At any point in the conversation, you can raise your virtual hand and our distance learning specialist will send you a private chat message to support your needs. All attendees will be entered into a raffle to win a $100 Amazon gift card. We'll share the lucky winner in our follow-up email at the end of the day, along with a recording of this webinar for you to reference moving forward. So what can you expect to see today? During our chemistry live demo, our chief resident scientist, Dr. Duane Cagle, will show you how to investigate the structure, properties, and transformations of matter with HOL's rigorous online curriculum and the powerful platform that hosts the content from both an instructor and student perspective. Before I introduce our host and distance learning specialist, let's get an idea of our audience's proficiency with online lab learning by launching the poll now. All right, it looks like we have a nice mix between instructors who have done this in the past and those who are new to distance learning labs. Thanks for participating. If you don't already know our host today, Dr. Duane Cagle is our chief resident scientist and has been the brains behind Hands-On Labs curriculum development for the past 9 years. We also have several HOL distance learning specialists on the call today who will be manning the chat and providing helpful resources throughout the webinar. A warm welcome to Pam Peisewang, Taylor Lewillier, Amanda Biggs, Eric Kenyon, and our main host, Dr. Duane Cagle.
Thank you so much, Justin, for the warm welcome. And more importantly, thank you to all of our guests who are joining the webinar today. We know these are interesting times for all educators, and whether by choice or force, you are looking to take your chemistry laboratory course online this fall. We want to first assure you that we've been in business supporting online laboratory science courses for over 2 decades. So we have plenty of experience in accommodating the needs of you and your students. So what I want to spend time with today is sharing with you our laboratory curriculum, our materials, and then also our interactive cloud-based lab manual platform called HOL Cloud. And we'll spend the bulk of our time together this afternoon looking at the student experience when using both our materials, curriculum, and our learning platform. And then we'll conclude today's session by exploring some unique instructor tools to facilitate your instructional efforts for your online laboratory course. So to get started, I'm sharing my screen right now of the landing page for a student taking an online chemistry laboratory course. And so this is the home page for the HOL Cloud platform. And we'll see in this course that the student has a variety of lessons assigned. 2 of them are labeled prerequisites. And then the following 5 are the lessons, the laboratory experiences themselves. At the top of the page, the student is encountering a welcome message from their instructor, reminding them to complete all the prerequisites before they begin to use the materials, physical items in their lab kit. And I want to spend a little bit of time talking about how important prerequisite lessons are. And I think this will address a lot of the concerns you have of leaping into the unknown of teaching your laboratory course online. Now, I know that your main concern is safety when it comes to chemistry labs. And I also know, as having been a chemistry student way back long ago for multiple courses, that the first thing we did in the laboratory was spend at least a partial, if not complete, lab session on lab safety. And indeed, we have included that as a prerequisite in our lab manual curriculum. Safety is paramount for our company. We have partnered with a number of entities to assure the proper packaging of the physical materials in our kit and that our curriculum is designed in as safe a manner as possible, to the effect that we provide liability coverage for the end user of our curriculum and kits, i.e. students, should they incur any accident while conducting experiments. So rest assured that neither you nor the institution that employs you is liable should students incur an injury using our physical materials. Now, having said all of that, we are more than happy to announce that in 2 decades of being in this industry, we have had absolutely 0 liability claims on our policy. And again, it has to do with our foresight and planning from both the material standpoint and the curricular standpoint to assure that students proceed in the safest manner possible. The other prerequisite is called Getting Started. This is an interactive lab manual, and we need to assure that the students know how to use all of the functions built into this platform to successfully answer questions, submit work, and just navigate through the platform in general. So they have a training session called Getting Started before they have to ever apply those skills in the labs themselves. So for time's sake, though, we're not going to walk through each of those prerequisites other than the description I've just shared with you. I want to focus our time together today on the actual curriculum and the physical materials that students use to conduct hands-on laboratory experiments. So these are just arranged in alphabetical order. I know from how chemistry labs work that this would not be the order you would teach these topics in, but it is going to be the order that we look at them today. Now, you'll notice as a student, when I click the first title under the lessons section, that I get a drop down, and the lesson is divided into sections. And those sections all begin with E. First section, exploration, the following 3, exercise, and the final section, evaluation. And indeed, these sections are gated for all lab manual topics, meaning a student must complete each section of the lab in sequential order in order to progress through the lab. So I can't, as a student, click on acid-base chemistry and immediately take the evaluation. I must proceed in the order that the lab is arranged. So let's do just that. So when I enter the exploration, I encounter as a student a landing page. And at the top of that landing page, I'm reminded that this lab is divided into sections. And specifically, these sections are titled exploration, experimentation, and evaluation. Now, if you've had any teaching theory courses in your background, you may recognize these terms as being part of the 5 E's of science learning. So within the lab manual portion of your course, we have provided with 3 of those 5 E's. Directly below the subtitle headings is the estimated completion time display. And this is very important for online science laboratory students. You know, unlike their on-campus peers, they are not showing up to campus for 1 to 3 hours per week for 1 or more days per week. It is really upon the student to plan and allocate their time appropriately so that they can be successful with completing their laboratory activities. So it is imperative that we, the curriculum designers, present this information to your students, not only on this exploration landing page, but you'll see it again on the experimentation and evaluation landings also. Now, towards the bottom of the page, the student is going to encounter clearly written learning objectives. And again, if you have a teaching theory background, you'll recognize the structure of these in that they are written in according to Bloom's taxonomy. And Bloom's taxonomy is part of constructivist learning theory. Basically, it just means that a learner gains new knowledge by building on existing knowledge. So these labs are set up to follow that format. So in the exploration section, a student is going to be introduced to the fundamental concepts they need to understand before they proceed to any hands-on procedures, which are then covered in the experimentation phase and connotate a higher level of understanding once those procedures are completed. So the learning objectives that we're going to see here are low-level stakes learning and begin with verbs such as describe, define, and compare. Now, before a student begins interacting with the exploration content, they first need to complete a pre-test, test your knowledge activity. And that's the blue bar at the bottom of the page. Now, when the student clicks this bar, they are presented with a series of drag and drop questions. More specifically, these are formative assessments. They are designed to test a student's inbound knowledge of the subject matter that is represented in this particular laboratory. Now, ideally, you will have covered this subject matter in the lecture portion of your chemistry course. And then the student would follow that up by completing the laboratory portion of the course, just as things work on campus. Well, here's something that might be surprising for you. It doesn't always work that way online. Because students have to allocate and set aside time on their own to be successful in the laboratory portion of their course, you may find that students work ahead. So indeed, they may need to complete the laboratory portion for a particular topic in your course before you introduce that topic in your lecture section. For that reason, it is imperative that a student be made aware of how much they know, but more importantly, concepts they don't yet understand before they interact with this particular lab manual chapter. Now, all of these activities are drag and drop. If this were a live student instance, I could actually drag and drop these. But what I will show you is what the results look like. So what happens is the student drags and drops, they hit a submit button, and they are provided with immediate feedback before they even move on to the next question. And that feedback looks something like this. So here we see this very same question that we were just looking at. The student has answered it. They hit the check answer button down in the corner, and they are provided with the feedback, i.e. the results of their efforts. And this particular student only got one of the potentially 4 choices correct. This is important. Now the student has been made aware of what they don't know. And studies show that as a learner, once I am aware of what I don't know, when I encounter that information in the future, my brain just focuses on it. It's weird, and it really does work. So we want to apply to that theory because it is a best practice for online students. The other best practice about this type of questions is their drag and drop format. You know, studies show that the most engaging activity that an online learner can have with an interactive platform is a drag and drop activity. So we want to make sure that's the first activity that a new student engages with within this interactive lab manual. So let's look at examples of other questions. Other drag and drop test your knowledge questions may be categorical in nature, where students drag and drop, in this case, formulas to identify them as acids or bases. They could also, here's another example of a category question. This is based on pH indicator colors for various substances. And then lastly, they could be a labeling feature. In this case, they're labeling parts of a chemical formula. They could be labeling a diagram or anything along those lines. Again, as soon as a student answers each of these activities, they are provided with immediate feedback. Now, as a student, once I've completed this, I should have identified any knowledge gaps I have related to the topics covered in this lab. I can now interact with the content itself. And the bulk of the exploration section is composed of text pages arranged with very manageable blocks of text with all important terms in bold, always followed by graphic representations of those concepts. So students remain visually engaged while covering the background content. Now, this content is textbook agnostic. It's designed to introduce a student to all the concepts they need to understand before conducting any procedures. Hopefully this is just a review for students, but if it's not, we want to provide the content in enough detail that they will be successful in understanding the outcomes of their experimental procedures. Now, at the bottom of each of these content pages, the student's going to encounter another activity panel. And this one's labeled question time. And question time questions are always multiple choice or true false in format, and they are designed to assess the student's understanding of the content provided on that particular exploration page. So before a student advances to the next page, they need to demonstrate that they do understand the main concepts on this page. Again, they're multiple choice. Matching is a type of multiple choice. Here's a more multiple choice proper question. When the student clicks their answer, again, they are provided with immediate feedback. We see an example of that here, where this student got this question wrong, and then they're shown in yellow with a check mark what the correct answer should have been, and they're shown with that correct answer in a feedback box at the bottom within the question as it's stated. A student can X out of these once they've answered and stay on the page, or they can keep advancing on to the next exploration page, as I have done here. So now the presentation is getting a little more detailed from the basic concepts of acid and bases to pH and the pH scale and pH indicators. Again, the content is interspersed with graphic representations. And at the bottom of this page, there's a Did You Know panel. Did You Know panels are designed to allow students to relate new content to information that they already understand. And then here's more question activities for the student to complete before advancing. Now, for time's sake, I'm going to go ahead and move through this lesson. But your students are not able to do that. They have to complete each page and answer the questions at the bottom before proceeding. So let's take a look at the next section of a typical lab, and it's titled Experimentation. Now, as you might imagine, this is the section that contains the step-by-step procedural instructions for the student to use the materials in their lab kit. Again, what do we see on this page? On this landing page, again, we see the estimated completion time, reminding the students that they need to set aside 2 hours to complete all the activities for the hands-on procedures and data analysis associated with those procedures. The learning objectives are at the bottom of the page. You'll notice there are more active type of learning activities represented in those statements. Following the overview page is the materials page. And we break our materials down for each student into student supplied items, which are non-science materials, and they're designed to help the student clean up after procedures, or in this case, students are going to be testing some household items in addition to the chemicals that we provide them with. And then most importantly, there are the HOL supplied materials. These are the items in their lab kit, and you'll see that they are science related, such as safety equipment like gloves and goggles. In this particular lab, the pH strips, test tube cleaning brush, a well plate, and you'll see how that's used coming up, and then a bag full of numerous compounds. You will notice not only the variety of chemicals provided for the student in this lab, but also the volume of each. The volumes are very small, ranging from 2 to 3 milliliters per compound. Again, we know safety is a concern of yours. It's also a very big concern of ours. We also know cleanup and disposal of leftovers is a concern of yours on campus. And it's certainly a concern of ours for our end users, your students. So by providing students with very small amounts of chemicals, any disposal needs are minimized, and the residuals they have at the end of the experiment are really not concerning for the student, or should not be concerning for any jurisdiction when we're talking about 20 drops of the chemical at most being left over. Obviously, the spent chemicals in the reactions have been neutralized by the reaction, so they pose no harm either. And then from a safety standpoint, you'll see momentarily how these chemicals are disseminated from the containers. You'll realize there's no danger to students in the terms of spills or anything like that. So let's take a look at these compounds, how they're packaged, and how the students use them. So this is one of 3 exercises in this particular lab. And you'll notice after a couple of introductory statements, the student is supplied with a video. In this video, I'm going to mute the volume so we don't get feedback, but this video shows a student exactly how to use these prepackaged chemical dropper pipettes by removing the heat-sealed tips and then positioning them upside down in a well plate so they don't have to worry about them toppling or leaking during the procedures. And we intersperse videos whenever possible throughout the procedures of our experiment. Here we see the setup for the procedures themselves, where a student is using a well plate, drawing a grid. You'll notice it's visually rich, meaning there's only a few step-by-step instructions immediately followed up by a photograph to visually guide the student through the procedures. If you were to ask me what the main challenge for a remote science student is, it's not time allocation. I would say that's number 2. The main challenge that your remote science laboratory students have is they cannot get immediate answers to any questions that they have, compared to their on-campus peers who merely raise their hand and have their teaching assistant or instructor walk over and provide them with guidance. So because these remote students can't get immediate answers, it is imperative that we reduce any questions that they might have. And we do that by writing very purposeful steps, beginning with verbs, very short in nature, and always following those up with photographs of the actual materials and protocols that the student is using. Here you see a student distributing some of this particular compound in one or more wells, and it shows the student how to prepare and then how to actually interpret and use pH paper. We've included a video for them Also, we call out various data tables for students to record their observations and experimental outcomes. And students locate their data tables in the lower right-hand corner of their computing screen, as we see here. And when I click on it as a student, that data table automatically expands to the volume of the area of my screen. And this is very, very important because we've designed our curriculum and our platform to be device agnostic, meaning students don't need to be using a traditional desktop computer to access their curriculum. They can access it through also a notebook or laptop computer, which obviously most students have, but they can even use a mobility device like a tablet. And if the student is using a tablet, you know, they probably don't have a traditional Windows program where they can toggle between windows or toggle between documents and different types of software easily. So it is imperative that we integrate all the tools that a student needs to complete their work from an IT standpoint within the lab manual environment. And so these expandable data tabs certainly facilitate students using smaller screened devices. Once I've input my answers as a student, I can easily click the data tab again and it minimizes, so my curriculum page is exposed. After the procedures, I have cleanup instructions followed by exercise questions. Now you'll notice that these questions are not interactive, meaning I'm not just clicking or dragging and dropping. I actually have to type in an answer here. And this is important because the exercise questions are designed for students to relate their experimental outcomes to the concepts being addressed in the lab. These are short answer by nature, although we don't put a word limit on it, so the student can answer in as many sentences as they deem necessary to demonstrate their understanding of the concepts. Now, many labs have more than one exercise, and this one does. For time's sake, we're not going to go through the other two with any kind of detail, but you can see there are 3 exercises for the student to complete. Now, because I'm not a real student, I can jump ahead. So I'm going to jump ahead to the evaluation section, and you'll see again that the first thing I'm reminded of as a student is how much time I need to allocate to be successful with this section. And this relates about 30 minutes. And then I am provided with a review of all the learning objectives for this lab. So I can review and reflect on my accomplishments thus far. Once I've done that, I'm ready to begin the actual exam, the evaluation. And the exam consists of a dozen or so multiple choice questions. And when I begin these as a real student, I'm provided with a note that communicates to me that once I begin this final exam, I am locked out of my lesson, meaning I cannot return to the exploration section or the experimentation section to look up content in order to answer these questions. So this is very much a lab practical, if you will, over just this lab. And these questions span the breadth of the lab. So they span things from simple definitions to experimental outcomes, to procedural protocols, to data analysis, and then to the student kind of visualizing and expressing what it all means. And so each of these questions is associated with a learning objective, and everything is tracked internally. So both we on the curriculum design end and you on the instructional end can monitor how many of the learning concepts your students have mastered by the end of each lab. Now, again, these are all multiple choice questions like we saw at the bottom of each exploration page. And once a student answers all of them and they hit submit, they are provided with a final report, and they're provided with detailed feedback where they are shown which ones they got right, which ones they got wrong. They can't re-answer these questions. They can go back and review if they would like, but this is truly an exam, so they get one shot at it. And then lastly, before leaving this lab altogether, students encounter one or more extension questions. And extension questions allow students to build or apply the knowledge that they've gained from conducting the procedures to address a new type of exercise or address a whole new concept. So these are application-based questions. Students have not performed these activities at all during the lab, but they're expected to draw on the concepts that they learned by completing the lab in order to successfully answer these open-ended questions. So and then there's some certification statements that students are expected to make before they finally complete all the activities in the lab and then unlock the next lab topic for their completion. So that concludes a quick overview of a student experience when using our physical materials and our interactive lab manual. We offered the student a couple other quick tools at their disposal. One is a detailed materials list. Remember, in most procedures, students are expected to supply common household items since we just ship lab materials. But students can review all student-supplied materials for the entire course at one time using the Materials tab. So if they identify any items that they don't currently have on hand, they don't need to, they can just make one shopping trip and get everything. So they're not constantly realizing, oh, I'm about to do these procedures and I don't have what I need. So we give the students plenty of notice. And also, there may be times when it's advantageous for students to actually have a downloadable file that they can use for whatever reason. So like, for example, in all of our chemistry courses, we offer the student a very expandable, downloadable periodic table file that's much easier for them to reference than if it was merely just a smaller image within the lab manual itself. So that concludes the student overview. I'm going to take a quick breath here. I will encourage the panelists to forward me any questions that they may have encountered related to the student experience using our material that they're not comfortable answering. And I'll take a quick minute to answer those before we look at some really exciting instructor tools that we've created within the lab manual platform to facilitate you teaching your course.
Thank you, Dr. Duane. So we do have a couple questions. The first one is, when students are required to finish only a specific part of the lab, what is the best way to submit their lab report for the instructor to grade it? In this case, this professor has had a lot of students reach out saying that they were unable to submit an unfinished quote unquote report.
So I guess you're saying that if you only wanted students to do a particular exercise instead of multiple exercises, so you're a current user, I'm guessing. So what your students need to do is they just need to type some kind of data entry into the cells for the other exercises. It doesn't have to be anything. It can just be an X per question, just a quick X. And that'll let the system know that the student has entered something. As far as data tables and upload panels and things like that, they shouldn't require the student to complete before advancing. It's just those end of exercise questions. So easily you could just have your students type an X or their initials or anything into any of those exercise panels that you don't want them to complete, and the system will let them move forward after that. It's very easy. Thank you for the question.
Great, thank you. We have a couple questions regarding the materials. that come in the kit, are they plastic or glass? And another question to move on that is what kind of glassware is used for a titration?
So we use both glass and plastic labware, and the choice between materials composition is based on how the material is going to be used. So obviously, if we're having students heat a material, then they are going to use glassware for that. So such as glass beakers, for example, to go with our burning elements and burner stands and all of that. So we are not expecting students to use a kitchen stove and kitchen cookware for this. So this is not the age-old kitchen chemistry by any sense. So if we're expecting a student to boil a solution or heat it to a certain temperature, then we are providing them with all the means to do that, and therefore the requisite glassware at the same time. So as far as titrations go, more often than not, we're using titrations with a syringe, a large syringe, and a titration adapter at the bottom of it. I don't think one of the sample labs I have up on my screen today shows that, but we have numerous titration labs within our library, and we're happy to share any of those procedures with you after this webinar today.
Great, thank you. And one more quick question, I know we gotta move on. Is there a mechanism to minimize cheating in the competency questions?
Well, I mean, again, the students locked out of the exercises and the exploration content when they begin the competency review evaluation. You know, cheating is a concern that we all have as educators. And whether it was 20 years ago before online education became popular, or if it's today, it has existed, and I don't see it going away. Not that all students cheat by any means, but the resources out there, should they choose to do that, have existed and still do exist. You know, if we're talking about internet-based resources, there are plenty of third-party entities out there that are more than willing to pay money for some student to submit to them information that they can then turn around and sell to other students. And not only our own business, but many textbook providers that have interactive questions based into their digital textbooks, and other type of exam providers have looked at legal matters against these third parties, and the reality is you can close 10 of them down today and there's 20 more next month. So, so no matter what we do, we're always running to stand still, so to speak. When I get into some instructor tools in just a moment to share with you, I'm going to give you some more ideas along that line, so stay tuned for that.
All right, thank you. And then one more quick question. Do we have enough time, or should we hold it off until the end?
Let's move on right now, and then we can come back to that question at the end. So as promised, I wanted to share with you some instructor tools that we have built into our Lab Manual platform to facilitate you instructing your class. Instructing from not only providing your students with the content that you need to get to them, but also in assessing their efforts. So here we have the landing page for an instructor, and you'll notice it's quite different than the landing page we saw for the student, in that this is a dashboard. It shows me the names of all my students that are enrolled, their current progress in the class. We supply you with a legend so you can make sense of these various bubbles that appear by the students' names. And then you can choose various lessons to see where your class is in any given title in your course and how much time students are spending on each section within any given lesson. Most specifically, though, your drop-down menu is much more prolific than only the 3 options that we saw for the student. So you have a class list, This allows you to delete students from the course, from the lab manual platform, should they drop your course at your institution. It also gives you access to the lessons. Now, your access to the lessons is quite different than what we saw for this in the student view a few minutes ago. First of all, this is where you communicate with your students on their landing page. So you would have seen this message in student view earlier. You can delete a message to keep them time sensitive and add new messages at any time. As soon as you hit save, this message is pushed to student view. So this allows you to update your welcome content or important message content to students on the go. You also have the ability to rearrange the course flow for your labs. You know, when we turn over the lab manual, the labs are not arranged in any particular order. They're usually arranged by internal coding that's unique to each lab lesson itself. So when you receive them, it's imperative that you have the ability to drag and drop the titles in the order that matches the flow of your course. And then again, when your students log on to their lab manual, they'll see the order that you've created. You also have the ability to require sequential completion of labs. So meaning a student in this instance would have to complete a titration lab before beginning a separation lab, versus unclicking the box and students could randomly complete the labs in any order that they wanted. We actually have a lot more options beyond this, and I'm going to touch on that in just a couple of minutes. But at its most basic level, this is how you can adjust the flow of your course. Now, how can you add supplemental content for your students within existing labs? Well, you do that by going into the lab just as a student would. So you notice if we click on the anions lab, as an instructor, we still see the same sections that we saw as a student in the acid-base lab. The difference, though, is that when we get to the actual content pages of the exploration section, as an instructor, we encounter a series of these pulsing blue lines spread throughout the page. And at each of these blue lines, as an instructor, we can add supplemental content directly to the page. So we can add text, images, and we can embed videos. So if you wanted to expand on a particular topic that's already introduced in the lab manual, this is a wonderful opportunity for you to do that. Or conversely, if you wanted to add a whole new topic to the background content, again, you have the liberty to add all three of those visual elements to any content page. And when you do that, let's enter some text here. And you hit save. You see how it's highlighted in this beigeish gray background color. That is the same for your students' view. So any content, images, videos, etc., that you upload, your students' attention is immediately drawn towards it because it has a different background hue than the standard white background of the content that's provided in the lab manual itself. Now, we don't restrict your comments or additions to just the exploration section. You can do the same within the experiment proper. So if you wanted to add some clarification to any steps, you wanted to add some supplemental images, maybe you received a lab kit and you went through it and conducted the procedures and wanted to add a couple more photos, you are welcome to do that. And then another idea would be maybe your on-campus students do a similar lab, but obviously they're using quite different materials, you know, much larger volumes of chemicals. They're working in groups like typical on-campus labs will go. And maybe you wanted to film how that works on campus and introduce that video anywhere within the page. You can certainly do that. The only restriction on video is it needs to be MP4 formatted to be housed within the lab manual environment. So that is a very easy way for you to supplement the standard lab manual curriculum and push that content immediately to your students. Again, anytime you hit the save button after adding text, images, or videos, it's immediately viewable by your students. So what other tools and capabilities do you have as an instructor that allows you to facilitate your teaching efforts? Well, you have access to the materials list just like students do. So if you wanted to compile something or take some screenshots on your own and share with your students in advance of them ever receiving a kit or even logging on the platform, you are welcome to do that. Likewise, you have access to the Documents tab for your students. So if you wanted to upload additional files that you wanted students to be able to download on their computing devices, you are welcome to add to the files that we already house in the Documents tab. We provide you with answer keys for all of the short answer questions and all the data tables and any image and photograph upload panels that students complete. So if you would like a permanent reference for that you can store on your computer or even print, we've provided you with downloadable answer keys. But more sophisticated than that, we've built in a Gradebook tool for you. And the Gradebook tool allows you to do several things. You've seen these bubbles before. Once you complete the grading for each of these students, a little number will appear in the bubbles, which is their total score for each of the labs. And then, just as importantly, we've given you the ability to control the value for all the interactive questions that students answer both before the lab, during the exploration section, and in that competency review final exam. So if you choose not to grade those formative assessments, like many instructors don't, you can easily adjust each of them to 0. Students will still have to take them. Students are still going to get the feedback on which ones they got right or wrong. Students don't know how much point value you've assigned, but this at least then allows the final grades to be determined in the way that's most appropriate for your students. And then within the questions proper themselves, the short answer questions and all, you have the ability to grade each student within this platform. So let's see if we can't pull up one. Here we go. So let's go into the experimentation section for this student. And what we're going to see here is the answer key. So if you had downloaded one of those answer keys, this is what you would see as a standalone file. You would see all the data tables for each lab and what the outcomes were for the experiment as we conducted it in-house when we wrote the curriculum. Now, knowing your students' data may be a little bit different because there is always measurement error and just procedural error associated with any time we conduct an experiment. And then you will see your students' answers. So this particular student hasn't submitted their work yet for this particular data table, but if they had, you would see all of their answers. So it's very easy to compare. And then you can assign a grade for that particular data table based on what the student's results were. And then even more importantly is you can leave a note for your student, letting them know why you gave them the grade you did on that particular element. So then when your student revisits the lab, they will see in real time the notes you have communicated regarding their grade. So this is a much more efficient system than having a printed out report from your student that you manually grade and mark up as a PDF and then resubmit to your student. All of this is live and makes communication very, very easy and makes it easy for students then to log on and see the results of their submissions. But the ultimate customization of your laboratory course is accommodated through what we call our custom lesson authoring tool. And using the custom lesson authoring tool, you have the ability and access to all the content creation software that we have as curriculum designers at Hands-On Labs. So you can create an entire lab on your own. You can create just one big exam on your own. So if you wanted an overall practical at the end of the semester or at the midterm of the semester to cover a group of labs, you can use the custom lesson authoring tools to do just that. If you wanted to integrate lecture in with your lab topics, so where you would have a lecture for acid-base chemistry before the acid-base chemistry lab that we've built, you can create just a lecture component and then add it to the list of laboratory lessons that we've already housed on the platform. But bottom line is you have available the same litany of authoring tools that we do on our end to use to best suit the needs of your course. And we've taken things a little bit further than even that. And the last thing I want to share with you is learning technology integration. So we inevitably get questions in these presentations of, does your curriculum integrate into our learning management system? And the short answer is yes. And that integration can be as simple as you posting an enrollment link and an access link unique to your course within your learning management system. The students click on and then gain access to the lab manual that you may or may not have customized, totally up to you. Or learning technology integration can be as sophisticated as you embedding and breaking up multiple elements of the existing lab manual and interspersing it within your learning management environment, meaning that if you already have learning management pages built in dedicated to your lecture for particular topics, then you can insert what we call the hooks for a particular laboratory topic that we've written adjacent to your lecture topic. And it truly is a single unified experience for your students. So it's seamless. They're not physically visiting different websites or anything like that. It's all contained. Same thing goes for the Gradebook tool. If you are grading students' answers and obviously using the auto grading function for the interactive questions inside the lab manual, those can port, seamlessly into your Gradebook tool within your learning management system. We do have self-help documents on how to integrate our system within an existing learning management system. And we do have recorded webinars on that topic too. So we can assist as needed. But what you'll find, if you haven't looked into this in the past as an educator, if you've just been teaching on campus, your learning technology IT team, more often than not, once they're provided with this page that you're seeing on my screen, set everything up to however you want it set up in your learning management system. So that concludes an overview of Instructor Tools. You may have sent through some questions about ADA compliancy. We usually get those. I do want to share with you that our text is screen reader compatible on our platform. Our images have supplemental text associated with them for the visually impaired, as do our videos have closed captioning for the hearing impaired. And all of our drag and drop question features and our multiple choice questions are all keyboard accessible. So again, another example of ADA compliancy within our system. So that concludes this overview of both student and instructor experiences using both our curriculum and our physical materials. We have a few minutes left for questions, which I'm more than happy to address right now, and any closing comments from the rest of our team. So with that being said, I will turn this back over to Lindsay.
Perfect. Thank you, Dr. Duane. So we do have a couple more questions for you. The first one is a heat source like a Bunsen burner included in the kits? And how do students heat things up as part of the experiment?
Yes, we do provide a heat source for the laboratories that require heating for various reactions. And we use a burner and a stand for that, along with the glassware, obviously, to contain the solutions. So, yes, we provide all the requisite materials that a student needs on a science level. The only things we traditionally don't include in our kits are items, again, associated with cleanup of materials, or if students, let's say, you know, an immediate, two examples jump out at me right now. So like if we have an enzymes lab, which students are testing some enzymes that we provide on a couple food items. We have a caloric content of food lab where students are burning a couple of food items and then measuring how much heat is generated from that with, again, a beaker with water in it, amazingly. But anyway, measuring temperature change on that to determine calories burned. And so in those instances, we don't ship food items. So students would be expected to provide, you know, if it's a walnut or an almond or something like that. But again, students are given plenty notice on that.
Perfect. Thank you. And then we have another one about collection of data. So how is mass data collected? Is there a balance provided in the kit?
We do provide what we call a precision digital scale. It measures to 1/100th of a gram. That scale finds its way into most every chemistry kit, certainly all of our standard chemistry kits. So certainly if we're dealing with, you know, precipitation reactions, for example, limiting reactants types of equations and reactions, obviously a student is going to need to measure both the products or the reactants, I should say, of those materials. So yes, students are able to measure to 1/100th of a gram. We provide the student with all the tools within the data tables to record their numeric measurements. They have exponent functions and all built in to be able to answer questions and record data and a variety of symbols. So if students need to express formulas and things like that, they have the tools within the lab manual software to do so.
All right, perfect. So we have a couple more coming in regarding the heat source. With a Bunsen burner, the students must have access to natural gas. How does that work at home?
So we provide the students with a sterno burner. It's a sealed canister that's leak-proof and very safe to ship, unlike shipping goes with a lot of hydrocarbon sources. So that's the heat source that a student's being provided with. We've engineered a burner stand and the glassware that we use is the appropriate volume to accommodate that level of heat. So hopefully that answers your question. No, students are not using a laboratory Bunsen burner for the same reasons that the question was just posed at. And that, yes, we don't expect students to have a natural gas spigot on a lab bench like they would on campus.
All right. Thank you so much, Dr. Duane. I really appreciate your time and answering all of the questions today. We are out of time, unfortunately. I want to thank everyone for the engagement, for the great questions. Thank you so much for attending. We will be sending out a follow-up email with the recording to this webinar, as well as any resources that we discussed today. So thank you again, everyone, for joining, and have a great day.